Okay, then if we can do that, we can go on and measure them all over the place, which is fantastic. These represent 4 different continents. John Luca, where's that? Well done, Sicily. So I want to end up by taking this one step further and getting back to, I started by talking about this idea of different scales, about small scale and large scale, looking all the way from microhabitats to tidal level to geographic level. And we talked about how we can actually look at these different scales. Well, quite often we want to compare populations between places, between perhaps where you live here, perhaps further down the coast, perhaps even further down the coast, and perhaps even further down the coast. We might want to compare if these populations are different. And we could sample here and sample there, and we can compare. See, we got all the way down to South Carolina. See how cool that is? Yeah. Of course, there's about a 20-year difference from here to here. Yeah, you get to talk tomorrow. That's not so good. So this is also another area where we need replication. If we simply measured, so this is a coastline here, and we've measured, we're trying to compare between these 2 bays. We could say, and I want you to imagine this, okay, there's actually a pollution source here. Can you see it? Yeah. Fantastic, good, because I forgot to put it in. So there's a pollution source here, and this is a clean site, okay? Whew. Thanks. We could sample the population here, and this would be the population we get. We could sample the population here, and this would be the population, blue and red. And it looks that this pollution is having no effect on this population. Agree? Agreed. Fantastic. However, if we actually looked at this in a little bit more detail, and we actually sampled different sites within this area, what we'd find is that the populations are quite different. Within that area, there is also variability. But the variability is at a larger scale than just that population. So we need also to replicate the number of sites we do if we're going to do comparisons between sites. And then if we go and look at the blue population, what we find is that, whoa, hang on a minute. If we look at this group now, we look at the red one, if we look at the mean for this site, it's going to be over here. If we look at the mean for the blue site, it's actually going to be over here. And now all of a sudden, there does seem to be a difference between these sites. Because what we've done now is we have got a representative assessment of the populations in this area to compare with a representative assessment of the populations in that area. So we also need to think about this scale when we're trying to compare between sites. The same principles apply. And we can get round that sort of problem by using what are called hierarchical designs. And this is, for example, if we have 2 regions, named very aptly Region 1 and Region 2. We're scientists, remember? Within those regions, we have 3 different shores, and the 3 different shores here. And you can see the idea of looking at the scale here. We have replicates, which would compare between meters on the shore. We have transects, which would compare between tens of meters, 100 meters between shores, and then maybe thousands of meters between the 2 different regions. So we need to replicate at spatial scales as well. And this is also true for temporal scales, scales of trying to compare between one time and another time. The same principles apply. This is showing you here the abundance of 2 populations, this population here and this population here. And these show you the numbers, the changes in maybe our sea urchins, who knows. What you can see on the left is that there is no real pattern that's obvious. What you can see on the right is that there does seem to be a pattern where there are more at this time of the year than at the other time of the year. If we simply take 4 samples at any time, what you can end up with, perhaps we're measuring, for example, summer, spring, autumn, and winter, because that's what you get here, yeah? Is that right? Don't let them force you into thinking like that. We don't get summer, spring, autumn, and winter in Hong Kong, but all my students believe we have trees that shed their leaves before the snow comes. It's nuts. Sorry, it's just a little rant. I have them occasionally. I've got the tablets in my bag. I'll be fine. What we see here, so say this was summer, spring, autumn, and winter. If we took 1 sample at each time, this is the pattern we might get from taking the samples here, 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 and here. On the other side, and of course we've drawn this to show this, we get absolutely no pattern, even though there's a seasonal pattern. And that's because we're not describing the variation at these different time schemes. We're taking 1 point sample at that time. And so just like looking at variation at different spatial scales, we need to take variation at different temporal scales as well. So in each season, we would take at least 3 samples. So in the summer, we would go back randomly 3 times and sample that population. And when you do that, as you can see here, what you find is that you are able to replicate the true representative picture of how those populations change with time. So trying to look at temporal and spatial replication is very important. Okay, so we're getting towards the end. Thank God I can hear you say, So what I tried to do today was to look at how we could do things badly and ways that we could actually fix them. And like most of my talk, it's been stolen from other people. And this was first covered by a guy called Stuart Hilbert in a very influential paper back in 1978. There were people alive in 1978 and they wrote papers, okay? Now you might not be able to get them online, but they are there. And what he did is he went through all the errors you could make, and he gave us ways of fixing them. Good guy, okay? So he said that we could be biased. So to avoid bias, going, no sea urchins, 1 sea urchin. To avoid bias, we have randomization. So that's cool. We can make mistakes in how we count. If we make enough replicates, we should be able to get over those mistakes. 1 or 2 mistakes will get ironed out. There's lots of variability. Remember, this is what we're dealing with ecologists, is variability. Variability is difficult to deal with. And so we need to replicate at the right spatial and temporal scales to be able to do that. And that's especially important. We tend to forget temporal effects. We tend to only think about the here and now. We need to think a little bit more about temporal effects. There's also simple chance effects, and that means we need lots of replication. So Hilbert actually gave us a lot of ways that we could try and get over these problems. And I think one of the things I've tried to do today is to talk about those problems and how we can get over them. However, at the end of the day, he was also a very, very great realist. And he realized that no matter how hard you did these things, how carefully you did them, that in some way they were going to get screwed up at some time, okay? So he was able also to identify the importance of demonic intrusion. All right? And I think you need to take a note of this because it does happen more frequently than you may think. But because Stuart Hilbert was actually a nice guy, as I said, he also gave us ways of actually getting around these sorts of problems. So I think that if you do have this effect, then obviously the thing you need to go for is exorcism and human sacrifices. And I think coming from Boston, you're probably able to, there's Halloween coming up. I think you may be able to invoke some of these things that they may help you get the perfect sampling design. So what I want to end up with then is the fact these are a bunch of ecologists here. Okay, we talked about the fact that ecology is not rocket science, and Gary Larson knew this. He says, okay, my friends, we're not exactly rocket science because ecology is not rocket science. Actually, Tony says that ecology is actually much harder than rocket science. Rocket science is about simple measurements, linear dimensions. Okay, inches and centimeters make a difference, but they don't have to deal with variability. And ecologists have got to deal with variability all the time, and we have to find ways of getting over those problems of measuring that variability. But we can learn a lot from the variability. It's not simply which is an inconvenience. It tells us a lot about how populations respond to different processes, and that's what we're going to go and talk on a little bit about in the future. So I'd just like to end up by thanking Brian especially for bringing us over here, thanking you all for staying here and actually listening to us. As Brian's already mentioned, this is actually part of the INSHORE group. If anyone can name all those flags, I'll be amazed, okay? But they are all true. There's no fake ones there. But I'd especially also like to thank Ali, Jen, Francis, Jess, all the people who've been looking after us, because it's really difficult to look after us. And finally, I'm still here at the moment, and if you have any questions, then please, I'll be happy to take them. So thank you very much, ladies and gentlemen.